Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In our today's lecture, we will attempt certain questions from our review exercise chapter 11, and then we will also revise the classification of organic compound by classifying certain organic compounds into different groups and the subgroups. So starting from the MCQs from your chapter 11, encircle the correct answer. Condensed structural formula for butane is. Now you know that all the organic compounds having the prefix but means that organic compound contain 4 carbon atoms. Now the suffix "ane" is giving us the information that this organic compound is an alkane. Now since all the options contain the alkane, we will distinguish the butane from all other options by counting the number of carbon atom, and so our correct option is the option B. Option B is the condensed structure for butane because it contains 4 carbon atoms. Another MCQ. In this MCQ, a structure is given and we have to write the chemical formula for this structure. Now if you look at the structure, you will see that there are 3 carbon atoms, so we will be using the prefix "prop", and since it is an alkane, so we will use the suffix "ane". So this means that the structure for this chemical compound is propane. Now the third MCQ says which compound is not a saturated hydrocarbon. For saturated hydrocarbon, we have read that all those hydrocarbons are saturated in which all carbon-carbon bonds are single. So you may see here in the option A, all carbon-carbon bonds are single. In the option B, carbon-hydrogen bond is single. In option D, all carbon-carbon bonds are single. However, in option C, this carbon-carbon bond is not single, it contains a double bond. So this means that it is an unsaturated hydrocarbon. So for MCQ 3, correct option is option C, because in option C the given organic compound belongs to unsaturated hydrocarbon. The fourth MCQ asks that stem but stands for how many carbon atom, and we have read about it that it means that organic compound contains 4 carbon atoms. Pitch is produced by coal tar, coal gas or petroleum. We have read about it that pitch is the residue that is obtained after the collection of the coal tar. Now this is a short question and it asks that polyvinyl chloride is a polymer and it is used for making vinyl sheets, drainage pipes, wire insulation, etc., and it is obtained from vinyl chloride. Classify vinyl chloride as saturated or unsaturated compound. Now we have read about the polymers, that the polymers are the long chain compounds that are made up of repeating units called monomers. Now this vinyl chloride is the monomer of this polymer polyvinyl chloride. We have to classify it as saturated or unsaturated. We have talked about it before that all the saturated hydrocarbons contain single bond. All the bonds that are present between 2 carbon atoms are single bond. However, in unsaturated compounds, the carbon-carbon bonds are either at least one of the carbon-carbon bond contains double bond, or at least one of the carbon-carbon bond contains triple bond. So since this structure is having double bond, so therefore it is an unsaturated hydrocarbon and it is an alkene. Now we will do an activity related to the classification of organic compounds, and we have read this topic in our previous lecture. So let's revise certain concepts. First structure is the structure of pentane. You have read about the classification of organic compound, and before applying that classification, let's revise that how the organic compounds are classified. Organic compounds are mainly classified into two groups on the basis of carbon skeleton. What were those? Acyclic and the cyclic ones. Acyclic were further categorized into two subgroups: straight chain compounds and the branch chain compounds, whereas the cyclic were further divided into two groups: homocyclic and heterocyclic. Now, if you look at the structure of pentane, then you may see here that this is a acyclic compound, because here these two terminal carbon atoms are not connected to each other. So therefore it is an acyclic compound, and the subgroup to which it belongs is the straight chain hydrocarbon, because no other carbon atom is present on the sides of the chain. So therefore pentane is a straight chain hydrocarbon. Now we have another structure, that is the naphthalene. Now you may see here that since it is a cyclic structure, it contains a ring, so therefore it would be a cyclic compound. Now in cyclic compound, the subgroup it belongs is the homocyclic. It is a homocyclic organic compound. Why? Because all the carbon atoms in this ring are carbon atoms. So since no atom other than the carbon atom is present in the ring, therefore this naphthalene belongs to the subgroup homocyclic. If you draw the clear structure for naphthalene, then you may write it as like this. One hydrogen atom is attached to each carbon atom. Now you may see here that since all the atoms in this structure are carbon atoms, so therefore it is a homocyclic compound. Now let's look at another example. In this example you may see that there are 3 carbon atoms. So you may write this structure like this. Now by looking at this structure, you may see that this is a straight chain organic compound. Looking at this structure, you may see how many carbon atoms are there? 4 carbon atoms. So this means that the stem for this organic compound would be bute. But you may see here that all the carbon atoms are connected to each other in the form of ring. So therefore it is a cyclic compound. And it is a homocyclic organic compound, because all the atoms in the ring are carbon atoms. Now look at this structure. This structure contains 5 carbon atoms, and it is having a ring. All the carbon atoms are connected, so we will classify it as homocyclic organic compound. Now if you remember, then I have further divided the homocyclic group into 2 different categories. What were those? Alicyclic and aromatic. Now For aromatic, we knew that it should contain at least one benzene ring. Now, since this structure is not having any kind of benzene ring, so therefore this structure is an alicyclic homocyclic organic compound. Now, let's look at this structure. It looks a little bit tough, but don't get confused. Now you may see here that this is your chain. On this chain, two substituents are attached, that are CH3. So since two substituents are attached to this chain of an organic compound, therefore we will classify it as branch chain organic compound, and the branch chain organic compound belongs to the acyclic organic compounds. Now let's look at this structure. In this structure, you may see that this is your chain. Now since no other carbon atom is attached to the sides of this chain, therefore it would be classified as straight chain organic compound. So let's do a self-assessment exercise related to this topic. We are given 5 structures and we have to classify them accordingly. First structure, as we have read before, it contains 5 carbon atoms, so it is a pentane. Now, since there are no carbon atom present on the sides of the chain, therefore it is a straight chain organic compound. In the second case, you may see that this chain also does not contain any side group or substituent, so therefore your structure B is also a straight chain organic compound. Now let's look at the next 3 examples. The example C, as you may see here that a ring is present, so this means that it is a cyclic compound and belongs to the category of homocyclic organic compounds. Now let's look at structure D. In the structure D, you may see that this is your chain and one of the hydrogen atom on this chain has been replaced by the substituent OH. Now since a substituent is attached to the side of this chain, therefore this structure D can be classified as the branched chain organic compound. Any group that substitutes hydrogen atom on the sides of the chain is called as a substituent. So if a substituent is present on the sides of the chain, then that organic compound will be classified as a branch chain organic compound. Now for option C, you may see here that this is the chain of that organic compound and on this chain a substituent CH3 is attached. So therefore this organic compound would also be considered as a branch chain organic compound. So this is how you classify different organic compounds into different groups and the subgroups. This was all for today. Thank you for being with me.